that really is. So what is a vector? So first thing that I actually thought of when hearing the word vector, I've seen Despicable Me before, and I thought of this guy. So fun fact, his name is Vector, and what he says is a mathematical term. It's a line that defines both magnitude and direction. Oh yeah. And so, but when I first heard that, I didn't really know what these basically how to understand what the magnitude and direction actually means. So you think of it like a line. Think of it like this line right here. So it has both magnitude and direction. And so what magnitude really means, another word for it that I really thought of is length. So length, or really how much of something. So a vector can have, say, a velocity vector of this. A velocity vector is going this way, which is actually the direction, and it's going for a certain amount of distance, certain amount of speed, certain amount of acceleration. That is what the magnitude is, the length, or how much. And so for this right here, so the direction is basically where to, or where is it going. And so here's an example of that, of both of these. So this vector, so it could be the velocity of a car. So vector, the velocity vector of a car that is constantly going at 97 miles per hour north until it crashes into a wall. So look at that. If we look at this, so we know that the vector is a velocity vector, and it's of a car. So it's constantly going at a magnitude of 97 miles per hour. So it's constantly, that's basically how much. It's 97 miles per hour. And the direction, where's it going, is north. And so this would be north. So it's going north until it crashes into a wall. So, good luck to that person's arm. And here's another example. So yes, it could be distance, can be velocity. It could also be an acceleration. This is also very common application. So you think of an acceleration vector. This is supposed to be a cloud right here. These are the vector of the same size. So there's the acceleration of dogs and cats raining from the sky straight down at free fall. So now let's look. The magnitude, or the length, or how much. How much is the acceleration? And what that is, it's free fall. So, I mean, it's 9.8 meters per second. That's what the numerical answer. But free fall in this is just the word that we're looking for right here. And the direction, where's it going? Straight down. So that is what the vector is. The vector defines both the magnitude and the direction. So let's go to the next. And so the way that we, show what this vector really is, or what we write down is, there are different forms that it's put down. And it depends on what major you're in, or what you're studying, what you're learning, what your career path is. But for the majority of what I'm going to go through is going to be through this. So all these are component form. This is the component form of a vector. And so what these really mean, the 2 and the 2. So this part is the x value, and this is the y value. Because it's saying that it's going 2 units, and because it's positive, it's to the right, and then 2 units up, because it's positive. So you think of this vector right here. See how it's 1, 2, and then up 2. So this is vector right there. And it could also be written as this, with the pointy parentheses, basically. And I've noticed this one a lot in my physics class. This is something that you'll notice a lot with vectors. So sometimes it'll be written as 2i plus 2j. You could just basically think of it as the I is just basically the x values, and the j's are the y values. And then I'll go over this a little bit later on. But here, basically the x value, y value. So right here, and one of the nice things about vectors, is that no matter where on the graph it is, these vectors are the exact same thing. Because what really defines a vector is both the direction and the magnitude. These are going this way. This is same going this way. This is going this way. is the length. It doesn't matter the location at all, where it is. That doesn't matter. And so now let's go over let's do an example. So we already got that. So for negative 2 and 4, we got to remember that this is the x, and this is the y. And because there's the negative sign right there, you must make sure that it goes left. So say we want to start at the origin. So 0, 0. So we go left 2, 1, 2, and then up 4. 1, 2, 3, 4. So that's where it's going to end. So it's going to be from the origin right there. Right, there we go. Cool. I'll make it straighter. So negative 2, 4. So that's what a vector is. So this is saying that it's going left 2 and up 4. So that's both the magnitude and the direction, or really the direction. And it doesn't matter no matter where it is. So say start right here. Okay, I go 1, 2, 1, 2, 3, 4. That is the same vector. And no matter where else it is, we can move this here, 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 here. It is the exact same vector. So that's what this is what the component form would be. It would be negative 2, 4. So that's just for 2D. But as we learned in previous math classes, we can have a 2D plane, and we could draw a whole bunch of lines, and in our case, vectors. But we could also do the same thing with 3-dimensionals. And so what you would do for that is basically the exact same thing. You do negative 2, 4, but in the new case, there's going to be a third value, and that's going to be the z, so x, y, and z. And so you remember how over here, when we went over this, the I and the j, that's just the x and the y. So we add a k for the z, so that's how we can tell if it's 3D. So the most simplest and easy way that I've seen, I've learned this from, there's a YouTube channel called The Organic Chemistry Teacher. See, he taught me how to do it like this. So I have the z vertical, the y horizontal, and the x at this. And I think it makes sense, and I'll go over how to do it. So this, for example, the vector 2, 3, 7. So think of it like this. So first, when you're graphing a point or graphing a line, you start with the very first one, the x. So you go in the x direction, 2. So that's 1, 2. Good, we started there. Now we go to the next point, 3. 1, 2, 3. And when you're going in the direction of the next one, you want to make sure that you're going in the parallel line as where you're going. So this is y. You want to make it parallel right here. So you want to go 3, 1, 2, 3. So that's where we get here. Now it's time for the z direction. See how it's going up? So you go up 7. So 1, 2, 3, 4, 5, 6, 7. And that's where it's going to end. And so that is how we get there. And so that's the reason why I drew some dotted lines, to make sure you can actually kind of perceive it in 3D. It kind of looks like it. And so now we could do the point 4, 9, 1. So in yellow. So remember how we first got to start the x. Because that's x, that's y, and that's z. Okay, so we start at 4. So 1, 2, 3. And now let's make this 4 right here. So 4. Now we're going to go to the right, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, 9. Now up 1. Right here. Cool. And then since we start at the origin, you go right there. Pow. And that is what it looks like. So go up 1. There we go. And it's also a good idea to go diagonal too. because that's going to be diagonal to this line right here. So now it looks kind of 3D. So that's how we do that one. And now let's do the 5, 2, 8. Vector 5, 2, 8. Sweet. So now we went 4 right here for the last one. And so we'll do one more over here. So 5. Now we're going to go in the y direction. 1, 2. So we're going to make it right here. And then, so we got 5, 2, and then up 8. So 1, 2, 3, 4, 5, 6, 7, 8. Alright, so make it right there. Start from the origin. Right here. Okay. And that's what it looks like. Cool. And so that's how you do it in vector. So these are all just like each individual vector. So now we focus on the direction. That's what the main focus has been so far. Now, how do we find the magnitude? Well, first let's think of it as an earlier math class. You remember a right triangle, how to find the last one? If you think of this like an A side, a B side, and this is a C side, maybe that might sound familiar. So there's something pretty popular. It's called the Pythagorean theorem. A lot of people heard of it. I've definitely heard of it before this class. That is exactly how you find it, actually. Is a squared plus b squared equals c squared. So that is how we would find this. So that would be 3 squared plus 4 squared equals the question mark squared, which would end up being 25, then you need to do the square root of that, which is 5. So that equals 5. That's how we find the hypotenuse. And it's actually the exact same thing when we find the distance between 2 points. When we learned that, we learned it as the distance formula. So if you remember it, it would be the square roots of the change of x squared plus the change in y squared. Cool. And that's the distance formula. That's how we find it, basically right here to here. And for that, the change of x, that would be the 2 right here, and then also the 4 over here, so that would end up being 6. And so we'd put that as 6 squared plus, and then the change of y, so that's 0 and 4, so just 4 squared. And we do the square root. And that actually comes from the Pythagorean theorem right here. So think of this as a triangle. So that's A, this is B, that's the change of x, change of y. And the square root would actually end up being C, which is that. So that's the exact same thing with vectors. This is the magnitude that we're talking about. This is the length, or the how much that we're thinking about. And so if you think of it like this, hey, there you go, it's a vector. That's exactly the same thing. We want to find the magnitude, which is the length of that. And that's all we have to do is the distance formula, which is also the Pythagorean theorem. So that is how we find the magnitude. Alright, so let's practice with another one. So imagine we have a vector of 23 and 5. Now how would we do that? How would we find the magnitude? So the way that we would do it is we do again. Let's see. You look at the distance formula that we made, and we do 23 squared plus 5 squared. And do the square root of that. That is how we find the magnitude, because that's yet again the distance that we're thinking about, or the magnitude. And so there is a vocabulary in this class that we're all learning for all mathematicians so we can understand each other. And that's why we need to use the word magnitude. That is the more formal version of the word length, and like it just encompasses a lot of things, so we must remember that. And so I don't really want to simplify this, and I'm sure you guys don't want to either. So for my sake and your sake, we just keep it like that, and that could be our answer. Cool. And so now, this is just one vector that we're thinking about. Let's go to two vectors, and we call this vector addition. We add two vectors together, or even more. So think of it like this. Imagine we're in space right here. There are three astronauts. They're all playing baseball in space. So what happens for the first vector is we can have it. This yellow astronaut, he's throwing the baseball right here. He's throwing that baseball with a velocity vector of 17, 0. Because he's going 17 to the right as the x, and then 0 up. So he's going it straight this way. And so, but ending up, when he hits it, he makes it a little bit stronger, a little bit harder. So he's going to move it this way. And what we'll want for that vector, we can make it -15, 6. So that is the new vector from him. And so, you think like that yet again. So we're starting here. So we want to go left 15 because it's negative, and then up 6. And that is the new vector that we have right there. So he ends up catching it, so it stops. But it's going to be a constant velocity the whole time, and then a constant velocity from here to here. And so what we want to do, a lot of these problems, we want to figure out what is the resultant vector. So basically, what is it from here to here? And the way we do that is we actually add these together. We add the vectors together. And the way we do that is we take the vectors, if there's 2, 3, however many there are. Right now we only have 2. And what we're going to want to do is we keep all the x's together, and we keep the y's together. So x and y. So we're going to add them all together. So we do -15, -15 plus 17, plus 17, and then 0 plus 6. And that is going to be our new vector. So if we simplify that, that will equal to 2, 6. And that's going to be the resultant vector. So that is exactly what we're looking for. So if we think of it like that, so doesn't that actually look like it's 2? It looks like it's up 6. Because he's going up 6 and left 15. So it's just the resulting one. So that's how we do it for that. In other cases, with other instances, we can also subtract vectors using the exact same thing, but instead we would just have it a negative sign also. Awesome, cool. So, alright, now we just finished with 2 vectors. Let's go back to 1. Let's make it, give you guys some grace. So now we go back to multiplication. So right here we just did addition between between two vectors, but now we can multiply it or do scalar multiplication. This is another one of the math languages that we have is scalar multiplication. So what that basically means is we want to make it bigger, we want to make it smaller, and it's multiplying, just like we learned in other classes. So say, for example, we have vector A, which is represented by an A, and then an arrow with half a point on the top. That represents vector A. So what vector A is, we want it to be -2 and 6. And when we want to scalar multiply it, we want to make it 3 times. We want to do 3 times vector A. So what would we do? So just like with any other math that we've done, if there's parentheses, we distribute it in. So say for this 3, we distribute it in. So 3 times 2, -2, and 3 times 6. So here, for example, so 3 times -2 and 3 times 6. So what do I equal? Just -6, 18. See, easy enough? Cool. Alright, now let's use what we learned from here, and also what we learned from here, the addition. Let's put them all together. So, right now we have vector B of 3, 4, so it's going to the right, 3 up 4, and vector C, 2, 3. Now here's a question for you. We want to do vector B plus 2 vector C. So let's start by putting this one down, 3, 4. So 3, 4. And then what we can do is we can add that with 2 times vector C, which is just 2, 3. There we go. And now we want to add that in, add the 2 in. We want to distribute that or scale it. So that would be 3, 4 plus 4, 6. So 3, 4 plus 4, 6. So now we learned what we did before with the addition. Now I said 3 plus 4 and then 4 plus 6. So 3 plus 4 equals 7. And then 10. So that's what the answer would be. There we go. Cool. Alright. So now let's go on to vector equations. So we think of it like, before these are vectors, think of it just like a line. So now we're going to work with lines specifically. And when we can actually change how big the magnitude is. So think of it like a vector equation, like a regular equation. Think of it like y equals mx plus b. What we're so used to, we've grown up with that. Pretty nice. So the output is just y, the slope is m. The input, like what changes the y, is the input, so x. And then b is kind of like where you start. So in this case, right here, b would be where it starts in the origin, on the y-axis. That's where you start. The input is whatever x value is right here. So what's going to change it? And the slope is y over x. So y over x. The change. And then output is what we get up here. Now think of how that would be with vectors. What could be your guess? So this is the way that a vector equation would look like. So think of it as the same type of 4 things right here. So the output would just be an x and y vector. And just like what we were solving before, we're solving for the vector over here. And then the slope, remember how that's the change of y over x. So remember how that's just basically a vector. So x, y. So in this case, it would be AB. So that's the slope. And the input, the thing that would change it, is the t. So because many vectors that we work with are with velocity and acceleration and position, we like to use t for time. And time is usually one of the biggest factors that we put into. And so that's what we can distribute it into. And then where we're going to start, that's where we're going to start from. So say that we have a curve. Say that we have a curve right here. This is just a regular. In this case, it'd be y equal. Yeah, it's a parabola. Say something like that. Sorry, it looks kind of messy like me. So we're going to have that, but we want to have a line tangent at one of the points. So think of tangent in regular calculus. It's the slope at one point, and it's going to be from the line through that point and only touching that point. So right here, we want this tangent line. So that's what we're going to have to solve for this. How are we going to do that? Well, first, you got to look at the starting point. So look at the point right here. So say if it gave us that it was 1, 2, 3, 4, 5. Say it was at 5. That's what the C would be. So 5. And then we already know that it's above. Let's see, it's 1, 2, 3, 4, 5, 6, 7. Say it's about 7. So that's where we're going to start. And for line tangents, we're going to want to make something parallel, so having the same slope. So you'll find that a lot in math problems with vector equations. It's going to ask, we want to have a vector equation of something that's similar, that starts or that touches one point. So in this case, this. So we want to make it, if we want to make it the same slope, we got to make sure it actually has the same AB. So in this case, we want to make sure what the slope is right here. So say if they already give us the slope is just 3, 4. 3, 4. And then t, gonna add those together, and then x, y. Equals, alright, xy equals 3, 4t plus 5, 7. So sometimes it's going to ask, okay, what's the resultant vector? So now that we already figured out this, but they're going to ask like after 3 seconds. And so we just put the 3 in there, put that right there, and then we use exactly what we learned before. Remember when we did this right here, b plus 2c? Doesn't that really look like this? So this is kind of like the b, this is plus like the 3c. So now let's do that. So we're going to move this over here. Okay, cool. So think of it like 3 times 3, 4 plus 5, 7. That's what that would equal. This would be 3 times 3 equals 9. So 9, 12. It's 3 times 4. and do that plus this, plus 5, 7. Okay. So that's just 9 plus 5, which is 14. And then 7 plus 12, which is just 19. That is exactly what we're looking for. So that is the resultant vector. But if the question only asks, find the equation of the line tangent to this curve of the parabola at this point. So sometimes it'll just give, or just the t. Some will just give the t. And so it'll say, okay, t equals 5. So 5. Now you got to figure out which is up here. You got to figure out the y right there, and that's just going to be where you're going to start at. That's going to be at the point right here that we're going to talk about. And then when you find the slope right there, or the direction right there, just put a t in front of it, and that's what it is. But always make sure to have the equals xy. It wouldn't be an equation without that.